Hi, good afternoon. Thanks for coming for this session today. Today, we're going to share about the success story between Intel, AWS, and DBS on running this solution. And you're going to hear a lot from our speaker here on talking about this project itself. Unfortunately, the DBS Executive Director, Gempu, has last-minute changes, so he's not able to make it. So he actually did a video, and we're all going to get our AWS expert to actually finish the presentation on his behalf. Before I start, I just want to give you a bit of view about AWS-Intel relationship. We have been together since the start of the AWS. And you can imagine that 18 years ago, the only silicon you can talk about is actually Intel. So you can see that we have today about close to 60–70% of instances inside the AWS running on Intel. And the work we do with them is not just EC2. We help Intel optimization. We also have new services actually roll out from here. I'm quite sure my next speaker, Akasha, will talk a lot about that in the future. Yeah. And for those who are looking at jumping into the journey of the cloud with AWS, we have a program to support you. We have a program that looking at the partner. We have a program looking at end user. And basically, that gives you a bit of funding to actually address some of your concerns when you move into the cloud journey. Without further ado, I'm going to invite my next speaker, An, who will delve into details about AWS and DBS partnership.
Thank you, Jason. Hello, everyone. Thank you for coming today. It's late in the afternoon of Thursday, so hopefully after this, you're going to go and enjoy your replay. My name is Anjan. I lead the worldwide HPC and Quantum Specialist Solution Architect team. We are the part of the advanced computing team. Our team is working closely with customers in many industries and help them to migrate the HPC workload to AWS. In addition, we also work with a partner like Intel to help the customer, in this case, the DBS Bank, to migrate and build their workload on AWS. Today, I want to briefly talking about the financial risk management and risk modeling are some of the most popular workload migration and bursting to the cloud. Financial services organizations like bank rely on HPC calculation to calculate their risk or run portfolio analysis and provide the report to internal control or external regulator, or hedge fund leverage HPC for complex quantitative risk analysis, in particular area like high-frequency trading or AI-driven strategy. There are a number of regulations in financial services that require large-scale simulation using HPC. For example, FRTB, Fundamental Review of Trading Book, require 3x to 10x increase of compute capacity in the next few years, or CCAR or IFRS 17 for insurance only require large-scale simulation. We have many different financial services customers running on AWS, and here are some of the examples of customers that migrate the HPC workload on AWS. So what's driving this transformation? We have listened to customer pain point from running their HPC workload on AWS. Customers have told us that they want to reduce the runtime, innovate faster, or meet the regulatory requirement and increase the simulation from the market risk. They want to take advantage of large-scale simulation using the latest, greatest CPU, GPU, and storage, and also fast networking on AWS. They also want to modernize their algorithm, for example, rewrite their CPU application using GPU, or they also want to focus on business, and last but not least, reduce the IT complexity and also save costs. At AWS, we have a complete set of HPC, from HPC orchestration to cluster management like AWS Batch or AWS Pilot Cluster that many of financial services customers have been using to run their grid workload. We also provide a large set of HPC optimized instances low latency, high throughput EFA network. Also, different type of file system, such as FSx for Lustre, EFS or S3, they all meet FSI customer requirement. I want to go briefly about AWS Batch. We introduced AWS Batch for quite some time now. AWS Batch is a fully managed batch compute services that plan, schedule, and run your large-scale optimized HPC workload on AWS across the full range of AWS compute offerings, such as AWS ECS, AWS EKS, AWS Fargate, and Spot and on-demand instances. We have customers run million of core. For example, the Pasteur Institute run 2.1 million core on Graviton chipset to do the DNA analysis. And also, we have many financial customers using AWS Batch for their risk simulation. For example, like AQR and numeric. Another solution that we have is AWS Parallel Cluster. This is the open source solution, Slurm-based HPC solution that we provide for the user. You can go and download, you can run AWS Parallel Cluster using command line, integrated with our AWS services like FSx for Lustre, EC2, EFA, and NightDCV. We have many financial customers running AWS Parallel Cluster by quickly prototyping using Slurm-based or migrate their on-prem workload to AWS using Parallel Cluster. In addition to our current offering of AWS services and solutions like AWS Batch and AWS Parallel Cluster, and to address all those new requirements that I addressed and business driver that I mentioned previously, we have just launched a new HPC, managed HPC services called Parallel Computing Services, or PCS. PCS simplify the cluster setup, administration, and access management for the user. Some of the key features is we manage the cluster update and version upgrades for you, support the most popular scheduler like Slurm, and in the future, we're going to integrate more scheduler into PCS. Provide a unified compute and remote visualization management, and also allow the user to dynamically resource provisioning and scaling. Last but not least, we provide a rich set of telemetry, cost management, and also budgeting. How AWS PCS address the key customer need? Allow HPC. I'm sorry, it's automatically.
Not able to go forward or backwards?
Yeah, I'm sorry, it automatically run. Customer need to I'm sorry for the.
I'm very sorry, everyone. Give me a few seconds.
All right, so I can do this. Allow HPC administrator to maintain your cluster and support the user using rich telemetry and diagnostic. Also, simply upgrade the.
You want to stop for a few minutes until I get that fixed?
No, I think we can keep going. All right, sorry about this somehow. All right, so I think last but not least, one thing important is that I want to point out is that security on AWS is our job zero. We provide the most secure infrastructure, also the full set of security automation for the user to build the secure infrastructure and application on AWS. All right. All right, AWS won 6 Best Award at Supercomputing in Atlanta a few weeks ago, and Best APC Cloud Platform in 7 years running. And also, I would like to congratulate to DBS Bank to win the best use of HPC in financial services.
Hello, everybody. It's Gumpu from DBS Bank.
And
We
here,
are
I
a
would like
leading
to
bank
let you know
from
that
Asia. And
Wang
today,
Pu gonna run the
I will
video
share
quickly.
how we transform our quant and risk pricing engine in past few years with the help from AWS and Intel technologies. So this is today's agenda. I will introduce a bit about DBS and our team. Then I will share the business challenge facing our industry, which is the pricing needs. Then I will share how we develop QPE, which is one in-house solution to address all the challenges. Then we will share the design, the outcome, etc. Then finally, we will share Intel and AWS technologies, which has enabled this development. Thanks.
They're sending.
Okay, so this slide is a quick introduction of my bank, which is DBS. We are the biggest bank in Southeast Asia. And in the past 10 years, we have invested heavily in digitization, and we have achieved a lot of outcomes, which was well recognized in the industry. And my department, which is Global Financial Markets, handles DBS market trading. We are a leading player in many asset classes, providing full service to our banking customers, from retail to corporate to even financial institutions. Then my own team, the quant and tech team, we build pricing models and pricing engines to enable and scale up our trading business. So later, I will introduce a bit more on our business scenario. Let me proceed. Okay, I need to share with you what is pricing. So when the bank sells a financial product to our customer, or when we do a trade with our counterparty, we need to know the fair value of the product first. How to achieve this? The industry practice is to use math or AI models. So, a lot of algo, a lot of calculation involved to do all this pricing. Then the numbers churned out from this pricing they are very important, as they decide whether the bank can sell or trade with a suitable price, and also whether our customers can purchase a financial product with a fair price. So even after the trade is done, let's say the trade is 3 years or 10 years or even 50 years, for every day, our traders and our risk managers will still need to do pricing every day or even every moment, so that they know what's the current value of our positions. With that, our traders can do the risk management. Let's say if the market moves, right, they need to do a reprice, they know our exposure, then they can hedge. Without proper hedging, we may end up like Lehman Brothers. Okay, let me proceed again. Then let me introduce why this quant pricing load is a suitable load for HPC or for cloud. Firstly, we use a lot of simulation, which is Monte Carlo simulation, to do the pricing. This pricing demands a lot of calculations because usually we use 30,000 or even 100,000 simulation paths. So it means we do a lot of iterations to determine the price. With this, right, you can see a lot of calculation capacity is required. Then, every day we have a very large amount of pricing. No matter it's for customer pricing or for trader or risk managers revaluations, we do hundreds of millions pricing a day, and each pricing can be a certain level of pricing job. Then, all the pricings are independent. Means pricing A or pricing B and pricing C, they can run 100% separately. This also enables us to move the load to cloud because we don't need to link them together. We can distribute the job to different places, different servers. Then Because our load is very dynamic, let's say when customers want to price something, or when a market moves, we need to do a lot of risk revaluation. Then there's a big pricing load. And by then, we will need a big computing capacity. It's dynamic. And you can see why it's suitable for cloud, because cloud is on demand. Then lastly, the bank limits, let's say, customer or counterparty information to be shared to external parties. But luckily, for pricing, these are all numbers, all numeric stuff. So we can pass all these to, let's say, to a cloud provider for calculation without any worry on data breach issues. Okay, then let me share the technology challenge my industry faces. Due to the growing business needs, we need to develop more and more complex quant and math models. Then these models will require a lot more computing resource. And also, because the market is now more and more digitized, so our customers, because it's easier for them to compare price between different providers, so they also demand a very fast pricing. And also our traders, our risk managers, they demand a real-time P&L and risk calculation so that they can take action immediately. So all this leads to a need of a powerful and flexible pricing engine. But we have some challenge with our on-prem infra and our legacy pricing engines. Why so is because previously we spent a lot to build our on-prem infra. But the issue is the bank can only have a certain capacity because it's fixed. We cannot grow. And if we need to grow, we need to clear a lot of procedures. And usually the time to market is quite long. Also, it's quite costly to maintain on-prem. You need to support yourself, support staff, server room, the data patches, the server patches, whatever. And also, usually we cannot have access to the latest infra because the bank takes time to bring them in. And also, for the legacy pricing engines, because they are vendor provided, sometimes it takes very long for them to deliver the new products to us. And also, they charge us licensing cost. And also, it's difficult to scale up performance because, let's say, for example, a lot of softwares are charged per CPU. So with this limitation, you cannot scale up, let's say, as our wish because we only paid for, let's say, 1,000 or 2,000 copies. We cannot scale up easily. So this limited our growth. How to do that? Our solution is QPE. So we built a pricing engine by ourselves, 100% in-house. And we integrate our existing math and AI ML models. Then we build it to be very flexible with API, with microservice, so it can be easily integrated to DBS existing trading systems. Then we build it on AWS with Intel technologies. So it's 100% cloud native. So it means we can scale up our performance without any limitation. And we can already see the performance. We are doing 100 to 200 million pricings a day. Sometimes at the peak, right, we can support more than 10,000 per second. Then we also use GPU because AWS enabled us to use the latest GPU technology. So we build our CUDA speed up. With that, we can achieve 500 times acceleration. So our customer pricing, because of that, can be much faster. Then finally, this QPE in DBS has been powering more than a dozen different trading systems. So it's already generating a lot of business outcome. Okay, so this is our journey since 2018. Since we embarked on this journey with AWS and with Intel together. So we started with some asset class, then with the quick one with with the success seen by our management, by our traders, then we have more resource to quickly develop more products and more asset classes. So through the years, we have almost covered all DBS trading pricing needs. So now it's a central pricing engine for the bank. We cover most product pricing, even XVA, even data calibration, covering FX, EQ, IR, credit, etc., etc. Yeah. And along the way, we have building new products, we have building new features always. And this slide is a quick and simplified review of our architecture. So you can see it's not very complex because we prefer to be simple. We use Redis, which is Elastic Cache, to serve as our message queue and also as our data cache and also job queue. Then we use different CPU and GPU workers to talk to this Redis to fetch data, to fetch job, and to return results. So we have a very lightweight system design so that we can achieve a very high pricing efficiency. Later, we'll talk about that more. So in the design, we employ different AWS services from ECS, EC2, Elastic Cache, and others.
So again, thank you, Gampu. As you have seen, Gampu work through their journey to build their cloud-native QPE application and HPC platform on the cloud with AWS and Intel technology. Before I go deeper into that technology, I would like to highlight one thing. HPC had 5 pillars: application, orchestration, compute, storage or data, and network. And your HPC cluster or application will run as fast as the slowest one within that 5 pillars. DBS team has spent a lot of time and effort to optimize each of the pillars to maximize the performance. And QPE use many different technology, and some highlight are the application developed by using C++ and GPU CUDA to implement the pricing model. The application also is a REST API driven, and the team also use Redis Elastic Cluster for in-memory caching and data loading. Resilient framework. DBS had implemented very robust resilient framework for their QPE platform. There is no production downtime since 2019 and no need for regular maintenance. To increase the high availability service, they use multiple instances for high availability, also automatically detect and instant failure and replace it. To deal with job failure, which is very important for HPC application, they build their application with the job failure protection and auto resume when the instance come online. In addition, they implemented a well-architected infrastructure on AWS by utilizing multiple AZ in Singapore, also combined with their on-premise private cloud running on OpenShift. Performance requirement for a modern pricing engine. DBS work backward from the business driver. They need to price the IFQ super fast to stay competitive. Need to process super large load for risk monitoring, also had little tolerance for job failure. They're also very cost sensitive. Performance potential bottleneck. As I mentioned before, identifying bottleneck in HPC are very critical steps to maximize performance. In order to understand their job characteristic, the DBS team run using C++ code profiling from Intel, C++ compiling optimizer, and also adopt GPU to accelerate the application performance. They also did the memory profiling to optimize memory footprint. Also for networking, it's very critical to scale and increase the performance within the application. they use the message sharing and also message compression. Last but not least, to reduce the total read and write they implemented the Redis Elastic Cache cluster for fast data loading and also speed up the application. Another performance tuning metric, QPE scaling method. This is very important because the HPC need to know that when they're going to scale up, when they're going to scale down. The DBS team using the first technique is using the QDAP, or they call CPU utilization-based scaling, optimized for total throughput like risk reporting, also balance between cost and performance, suitable for large cluster. Another metric that they use is time-based scheduling, optimized for minimal response time and IFQ pricing, also more suitable for smaller cluster. The last metric that they use is the fixed capacity. This method is called hot pool techniques, meaning that they pre-warm their pooling, their pool of the capacity before the job run so that they can immediately processing. And this one, when you don't need, you need immediate need of capacity and also no cost sensitive. The job gonna run immediately. By looking at this graph, you will see that their QPE platform auto-scaling, when the load going up, it scale up, and then when there's no job running, the infrastructure completely scaled out to 0. As I mentioned previously, the DBS team has done multiple optimization end-to-end from CPU, memory, and networking. They also paid attention to the data loading time by implementing the Redis cluster for faster loading and save compute costs. This is some of the way that they tuning their Redis cluster. For example, using the Redis monitor on the Redis cluster to analyze the load of the Redis, also analyze the CPU and I/O of the Redis node, also using the partition technique to reduce the host key on the Redis and Elastic Cache cluster. Performance, maximize CPU utilization. One of the most important metrics within the HPC to achieve the 100% CPU utilization. We have seen that many on-prem cluster, HPC cluster, barely achieve between 25 to 40% of CPU utilization. Consequently, they waste a lot of CPU cycle and also memory. The graph here is showing that the lower graph is the load from the application. As you can see that the cluster and then so the QPE platform always achieve the 100% utilization, CPU utilization. Performance speed up from Intel technology. The DBS Quant team has been working closely with AWS and Intel team to optimize their QPE application with Intel architecture. In the past 2 years, QPE got a boost from Intel technology, for example, newer CPU, better C++ compiler, and here are some of the summary. They are using the C7 instances, C7i instances on AWS, powered by Intel 4th generation Intel Xeon Scalable processor, or codename Sapphire Rapid. They also use the Intel CPU parallel processing capability, C++ compiling technology, also Intel profiling tool that help them optimize their application performance. Speed up from GPU. This is very interesting because I mentioned before, customer would love to utilize the different CPU and GPU architecture on AWS. And DBS team also have utilized GPU to speed up their pricing model, especially the EQ and FS derivative IFQ pricing. Some of the highlight, The nature of GPU utilize 1,000 of small GPU core to run parallel computing, suitable for algorithm with many independent calculations like Monte Carlo simulation. They also have to consider cost versus speed. In GPU, they can achieve 50x or 100x performance, 50 to 500x faster performance, but also 50 to 200x more expensive. So they need to balance between cost and performance. Also need to build a special GPU model that can run on GPU. For example, there's some of the metric in that slide. They can run the IFQ pricing reduced from 1 second to 0.001 second, and runtime reduced from minute to under a second. Also, the FSO MLV calibration, they reduce from hour to minute by running on GPU. Additional technique. As you can see, they tuning application, orchestration layer, compute, networking, and also storage. They also apply other techniques like bandwidth throttling, load balancing, and also overlap async workflow to avoid bottleneck, cross-job data sharing to reduce duplicate computing. Balance is critical. We cannot design a system and a single goal because there must be a balance, including building effort in consideration. The DBS team has put a lot of effort in consideration in balance between business driver versus technical optimization. For example, they need to balance between performance, reliability, maintainability, build effort, and infrastructure cost. Some example, CPU versus GPU, cost versus speed. If they want to cache more data or less data, how they make decision between the scaling up, scaling down based on the application requirement. So the cost that's going to relate to that cost sensitive. QPE performance some number that you can, most customer IFQ pricing can be processed in 0.1 second to 1 second. Also, daily pricing 100,000 IFQ to the customer. And they can serve 100 million of risk revolution, and also overhead less than 2%. Right, the vendor licensing cost. Because of the QPE is 100% in-house solution, they successfully remove all the DBS licensing vendors software licensing and save a lot from the licensing cost. QPE shorter time to the markets and build new product. Because they are the in-house team, it's a quick and efficient communication between teams so that they can prioritize their alignment quickly. They also modeling capability built in the past 2 decades. They can reduce a lot of existing work from the previous generation. They also build a robust foundation of like resilient framework, flexible design by using API and microservices for expandability. How QPE enable business growth? So by utilize the QPE infrastructure and the HPC on AWS, they allow them to fast pricing speed, real-time customer IQ pricing, and help increase the customer satisfaction and help DBS strengthen its market value. Also, real-time infrastructure refresh enable trader to better manage their risk simulation and respond to market movement. Also allow them to come to markets faster, and also the less infrastructure bill by saving costs. How QPE development benefits from AWS and Intel technology? First of all, flexibility to choose from CPU, GPU instances virtual unlimited capacity, also access to the latest technology, and using a different metric, they can build a better application and HPC solution for the bank. They also use Amazon ECS to reduce the integration work on AWS. So now I would like to introduce Akansha from Intel to come up and talk about the AWS and Intel services engagement. Thank you.
Thank you, An. Afternoon, everybody. Wow. Do you guys want to come in a little closer? This is a very large room and very less amount of people. I guess we're standing in between this session and reply. So we'll try to make the rest of this as valuable as we have already kicked off with Gongpu as well as On. So I'm Akansha. I run Team Amazon at Intel and really excited to be here. I know it's the last day, but it's been an amazing journey at AWS reInvent. I hope you guys have had fun. I hope you have learned. With us in the industry, time and time again, we've recognized that when there is a technology that's accessible, that's consumable, and when the barriers of its adoption are low, this gives rise to a tremendous amount of demand. And through that demand rise various business models, various usage models, and ultimately, opportunity. Cloud computing continues to bend the curve on what is possible, and AWS is no exception. So AWS is one of our favorite partners. There's also something else that we recognize as Intel in the world of cloud. There are three things that Intel brings to the table to make cloud actually come into being. Number one, performance. Number two, performance. Number three, any guesses? Performance. Performance as well as cost and TCO efficiency is so important when you guys are taking your journey on AWS Cloud. And exactly to address that, we at Team Amazon do two kinds of things with AWS. One side of us makes sure that our latest and greatest of our processes are customized specifically for AWS's cloud. So as Jason mentioned, we have close to about 400 or 450 instances, and you would have heard Matt Garman talk about the couple of new instances that we've launched. We've launched the i7-IE instance today, as well as the U7 instance for SAP. But basically, what we do with AWS is we make sure that they get access to the latest and greatest of our instances, as well as our technologies, to ensure that we are able to, since the past 18 years, customize for your requirements by your application needs and what you want to move from your different worlds into AWS Cloud. And regardless of where or which service you're using, just make sure that you know, even if you don't want to know these specific instances, just know that Intel normally is always under the hood of all of the EC2 environments that you guys play around with. So if you look at the slide that I have, regardless of the applications that you guys are driving or using within your environment, whether it's SAP, whether it's storage, whether it's memory optimization, whether it's your HPC services that we've talked about, yes? And so basically, as you guys can see, we are making sure that we have optimized the journey. But once we have optimized AWS's cloud with our instances, there is the other side of Team Amazon at Intel that starts to work with you guys as our customers and partners to help you with the optimization journey. You saw a beautiful example right here because finance is continuously a very strong industry that's adopting cloud. The work that we've done with DBS is pretty special. And this exact optimization journey is what Team Amazon on the other side of the world also wants to make sure that we are offering that in partnership with our favorite friends, AWS. And so the typical journey that DBS took also, and of course all the rest of our customers, it's really threefold. So again, back to your response, if we did do benchmarking, if we did the optimization as well as execute towards the movement of your cloud journey, and then validate it by modernizing the availability of your applications, we will make sure that we can help you with the best cost benefit as well as the TCO for your cloud environment or your cloud infrastructure. It doesn't really matter which application. There's always some Intel instance under there that we can then unlock and unleash the juice of with our features that are built into our instances and make sure you see that end journey come alive. Now, we're at AWS reInvent, and probably this has been the war cry or rally since the beginning of every event that you guys have been attending. Definitely reInvent has been talking about how AI becomes a real reality, how Gen AI is going to transform the world. But I like to take this in a very different perspective. While we have AI, it's really just about data. We've got a Forrester survey that basically talks about the fact that by 2026, there's going to be 500 billion devices and over 7,000 billion sensors smartly connected over the internet. And 45% of those devices are going to communicate machine to machine. So what we need to think about, whether it's machine learning, whether it's deep learning, or it's Gen AI, we've got to figure out how we can make that data actually work for you and give you the insight so that you could build better products and be more successful in the market. And so that journey is more crucial for us to make sure that you validate the use cases, you validate the reason why you're taking on a Gen AI project, and then make sure that you've got a good community of people that can make that happen with the right type of skill sets. So regardless of which industry you sit in, Gen AI is a reality, machine learning and deep learning are a reality. Now, what does Intel bring to the table for AI? On actually talked about it, and so did Gungpoo. It's the conversation about choice. Cost, efficiency, performance. Now, whenever you guys pick up a Gen AI project, the auto default is a GPU instance. Every GPU instance has a CPU instance built under it. And so when you use Intel CPUs, we have a feature called AMX. It's called Advanced Matrix Extensions. These are AI features that if we unlock for you with your applications in your entire trained model journey, we will be able to help you boost your inference. And so once you have faster inference, your end production is going to be cheaper and faster just because you've unlocked a little bit of juice from our CPU instances. And that's the myth that we want to bust, that not every journey, not every LLM requires heavy, expensive accelerators. You can do them with your existing environment within the CPU spaces. And in addition to the fact that AI is everywhere and has been democratized, the other industry that has been democratized as well, I was just at supercomputing holding the award along with Ian on the HPC award that AWS won, but HPC has also become mainstream. Are any of you guys in the HPC world? Whether education, research? Okay, well, it has become that mainstream that you possibly need HPC within your world if you have a lot of number crunching to do, especially when there is data. You're possibly going to have to do a little bit of more HPC adoption, whether it's predicting the weather, whether it's curing cancer, doing better drug testing, or it's about making sure that you make better products or benches and chairs and manufacturing. Regardless of the HPC application, and I know that you shared the compilers and the performance analyzers that we have, but this is the actual stack that we applied with Gungpoo as well as his technical team at DBS to make sure that the performance optimization that I've been talking about comes alive. So not a lot of people, not a lot of you might even know that while Intel has silicon, what makes the silicon work is the software that sits on top of it. And over, I think it's been about 50 years, Intel has been building the best compilers that are on this planet. But in addition to the compilers, under our one API toolkit, we also have performance analyzers. We also have math kernel libraries that sit and make sure that your math functions are also as optimized. And then we also have cluster tools to make sure that if you've got some clusters, it gives you the right recommendations to ensure that your cluster is working far, fast, and wide. So working with the One API toolkit on your environments would be a super easy thing for us to do and enable for you. Make sure, again, join us on the engineering journey. AWS has all of the toolkits, so do we. And so really the key takeaways from today's session, you guys, we're very excited every single time that we have a success story like DBS on stage. But we'd love to see more. While AWS takes you on a journey for the migration that you guys are taking in or embarking on, we want to make sure that if there are Intel instances under the hood, we would love to work, collaborate, partner with AWS and make that journey more successful for you, faster for you, performant for you. So would love to open the stage up to make sure that you guys could come in and collaborate with us. We appreciate the partnership from AWS. Thank you, On, and thank you for the HPC team, and appreciate the partnership from DBS as well. We hope that we could do more with the workloads that they move to AWS. And then let's make sure that you guys take advantage of the existing solutions and the recipes that we built across the different industries and the customers that we have worked with. Really, that is the big point at the end of the day over here. In addition to that, maybe I would like to invite On and Jason back on stage to see if there are any other questions. Okay, awesome. Well, thank you so much, you guys. I know we've got 2 more hours. Come visit us at the booth because you don't want to get ready for replay instead. So come visit us at the booth. We've got some cool demos to show you about the different optimizations across different industries. Join us, learn more about us at amazon.com/Intel, and let's keep collaborating. Have a good rest of your day. Thank you.
Thank you.